Ignition sequence start.
Good morning. You're looking at Mission Control Houston and the International Space Station Flight Control Team, the specialists who are monitoring the state of systems on the orbiting laboratory and working with the Expedition 63 crew members as they move through their daily work. This week, Commander Chris Cassidy and his crewmates have been working with student-designed hardware while they've unpacked new supplies. They've also been getting ready for a new set of spacewalks starting 1 week from today.
Welcome to Space to Ground. I'm Catherine Clayton. This week we're highlighting the contributions of students from across the nation and a set of upcoming spacewalks. Sending supplies to the International Space Station requires a different packing method than the luggage we use to travel on Earth. Special flight lockers are used to transport supplies from Earth to the International Space Station. 4 of these lockers launched on the SpaceX Demo 2 flight to the station. The lockers are built by students from around the country through a program called NASA Hunch, or High School Students United with NASA to Create Hardware. Hunch provides students an opportunity to play an active role in the space program. Students in 277 schools in 44 states can participate in one of 6 focus areas to produce items for spaceflight or training, such as the flight lockers. One of the student-built lockers will even return to Earth. Learn more about the Hunch program at nasahunch.com. NASA astronauts Chris Cassidy and Bob Lincoln are preparing for a set of spacewalks to continue the power upgrades on the station. On June 26th and July 1st, the astronauts will begin the replacement of batteries for one of the power channels on the ISS. The astronauts will replace aging nickel-hydrogen batteries on one of the power channels on the far starboard truss with new lithium-ion batteries that were delivered on the Japanese cargo ship last month. NASA TV and the NASA website will broadcast the spacewalks live so you can catch all the action. This week's question comes from Ben at RJO Intermediate School. Ben wants to know when the ISS was launched into space. The ISS began with the launch of a 41.2-foot module named Zarya. Zarya, which translates to sunrise in English, was launched on a 3-stage Russian Proton rocket from Kazakhstan, Russia on November 20, 1998. Continuous human presence on ISS didn't begin until the docking of Soyuz TM-31 to the ISS with the Expedition 1 crew.
The first expedition on Space Station requests permission to take the radio call sign Alpha.
This November, we will be celebrating 20 years of continuous human presence on the ISS in space. Keep sending in your questions using the hashtag AskNASA, and we'll see you next week.
We're counting down to 20 continuous years of humans on the International Space Station. Follow along at nasa.gov.
As Catherine mentioned, we have a spacewalk briefing coming up Wednesday at 1 p.m. Houston time to fill you in on the details of the spacewalks. Coverage of the first EVA begins next Friday, June 26 at 5 a.m. Central on NASA TV and nasa.gov. Cassidy and Benkin spent time on spacewalk prep this week, but the truth is preparations for a spacewalk actually begin before the crew members even launch. In this demonstration video, astronaut Ricky Arnold shares some of the training astronauts get on the ground to be ready to walk in space.
Welcome to the Quest airlock on the International Space Station. I'm Ricky Arnold, Expedition 56 flight engineer from NASA. Today we're going to talk about one of my favorite topics, extravehicular activity, or EVA. Going out on an EVA or a spacewalk has been one of the most amazing experiences of my life. But it's also one of the most complicated and dangerous things we do during human spaceflight. There's a lot of equipment to prepare and maintain, and we do months of training to make each EVA a success. If you think it sounds complicated, you should see all of it in action. Let's start with training and how we get ready for a spacewalk.
Space is an extreme environment that presents many hazards.
If we're going to go outside the safety of the ISS, we have to be prepared. That's why EVAs are designed with safety as the utmost priority. We astronauts spend a lot of time in the classroom, just like you are now, learning about the hardware we'll be using and the specific parts of the space station we'll be working on. Then we get to go spend a lot of time training in NASA's giant pool, called the Neutral Buoyancy Lab, or NBL. Since it's impossible to simulate microgravity on Earth, the next best option is water, 6.2 million gallons of it. The NBL is 40 feet deep, 202 feet in length, and 102 feet in width. A lot of room to have a full-scale working model of the ISS, which we need for practicing our EVA maneuvers and assigned tasks. We get suited up and weighted so that we're neutrally buoyant in the water, so we don't sink to the bottom and we don't float to the surface. It's a great way to simulate the microgravity we'll be experiencing. We do several dress rehearsals of the EVA before we launch. This gives us the opportunity to prepare for any anomalies that may occur. We spend at least 5 hours practicing in the NBL for every 1 hour planned for the spacewalk, so we are very well prepared to execute the EVAs once we are in orbit. Once we are up in orbit, the EVA preparation continues. First, we must perform a pre-breathe protocol to displace the nitrogen in our tissues and help prevent a condition called decompression sickness. During pre-breathe, we breathe 100% pure oxygen and do some light exercise to help purge the nitrogen from our bodies. During pre-breathe, we will also don our extravehicular mobility unit, or EMU. This is a fancy name for a spacesuit. The spacesuit is basically its own spacecraft, shaped like a human. There is usually a red stripe on the leg of one astronaut, but not the other, so the ground can tell who is who. To ensure our safety at all times, we are always aware of our safety tethers and where we are in relation to our spacewalking buddy.
Hey, buddy.
There's a fellow crew member called the IV, the intervehicular crew, on the inside of the airlock, watching and communicating with us as the EVA progresses. We are also prepared for several contingencies should they occur. First, we are trained on the use of a jetpack that can be used to maneuver in the event of an emergency rescue. It's called a SAFER, or Simplified Aid for EVA Rescue. The view during an EVA is magnificent. It's beautiful out there. It's also extremely dangerous, but our months of preparation and all of those dedicated people working on the ground, working around the clock, ensure we are safe as possible when we work outside the ISS. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
In a few minutes, we'll see Ricky Arnold again with a detailed review of the spacesuits the astronauts wear when they exit the vehicle. The scientists who imagine and create the experiments done on the International Space Station devote years to developing the research. Then the station crew members execute the protocols. What happens then when the results are returned to Earth? In this final segment of the new NASA Explorers series, watch the scientists take their research across the finish line.
So this is Emil. He is almost 8 months old now, and he was present for a lot of the testing that we did. He was also present for the launch in utero. And so over the course of our first ISS project, we made an entire new human along with all the other testing that we did. And this flight suit that he's wearing was from his Auntie Power Stew that we got when we were down at Cape Canaveral for the launch in December. And that's my favorite face he makes right now. Since he doesn't have any top teeth. So we were running concurrent experiments on Earth and on station. So Nanoracks had gels at their facility, and they were getting the data from the experiments running on station. And so we were looking at how the gels formed, their structure, and also how the drug release profile was changing given those two different environments.
Nanoracks brought the plates back to us, and we all made sure that we are here, and we opened the plates all together, and we had the same type of excitement that we had at Kennedy Space Center.
It was already exciting because space never loses its cool, and so we had these plates where, oh my god, these are what the astronauts touched. And so we opened them, and they've been to space and back, and now they're in our lab.
We could just at least look at them and see like how the integrity is different, if the structural changes are something that we can observe just by looking at the gel.
And when we looked at the data that we got from the equipment on station and the equipment from Nanoracks, we could see that there are differences in the drug release profiles from those gels that were happening at the same time.
We actually observed some interesting changes that we hope that we will be able to prove doing actual structural tests and more in-depth studies. But just by observation, it seemed like there might be some changes.
While the thrill of the rocket launch may be over, Elaine and Paris-Stu still have one of the most exciting parts of their journey ahead: publishing their results. This information could help inform future research on Earth and in space.
What we're working on now is compiling on that data and telling a good story around it so that it's something that we can, of course, publish and give back to the public. So we got some really interesting data from these experiments that were, again, super simple, but the story it might tell us could really inform material science as a whole.
You definitely feel a huge responsibility performing this research for others because you know how many years they've been working on the ground, and we often like to know the results. So personally, I stayed in touch with a lot of the scientists, and that gives us a lot of good feedback, and it gives us some closure too to know how important the science that we were doing up there really was.
I think Rachel has something for you guys.
Yeah.
Is it for real?
Oh my gosh!
Hi, Serena! Oh my god! How are you doing?
When they told me they were doing this, they said, hey, we'd like to try and set up at least a FaceTime call or something, and I was like, yeah, absolutely, this is great.
Oh, this is a fantastic surprise.
Where are you guys located?
So we're in our laboratory in Richmond, Virginia. So our other full-time employees are also women. So we're an entirely women-run company.
Fantastic.
It just turned out that way, but it's been wonderful because we're all women engineers.
Oh, hello.
This is our
joint. Oh, this is great. This is great.
Show you the plate that you'd handled in space.
We still have it. We still have our samples.
Oh, that's so cool. Man. See, it's even neat when we get to see the science back down in your hands, too. So sometimes it does go literally in a black box when we're up there, and we hope everything goes down safely. So, but thanks for letting me invade your space a little bit today, and good luck with everything you guys do scientifically, personally, professionally in the future.
All right. Thank you so much, Serena.
Cool. Yeah. All right.
Good talking to you.
Yeah, very nice to meet you.
And happy Halloween.
Happy Halloween. Yeah, it's hard to beat this.
Oh, I'm trying to think of anything that would be better than watching my own launch of research to the space station.
I actually have, like, my background of my cell phone is actually like the picture of us sending the product to the space station. Definitely a lot of people are surprised that young females in STEM have, this type of experiences and have contributed this much. I still look at the sky and I really think everything is so far away, and look at the stars and everything looks like nothing is achievable, but then just being a part of this whole experience, it just is a dream come true.
Elaine and Paris-Stu now join the thousands of scientists who've performed research aboard the International Space Station, making the most of what microgravity has to teach us. This dedicated group is bringing what they learn back to Earth, helping improve lives and advance exploration.
What Space Station gives us is a different sort of laboratory, and what's really meaningful to me is to be able to come back down and talk with my patients and let them know about some of the discoveries we made. This means a lot to me as a clinician, and so it was really neat to be able to perform that sort of science on station.
The energy that everyone has who's involved in space research is extremely contagious. And so you just get hyped up about it because everyone else is so excited about it. Yes, the timelines are long, but everyone is so positive and certain that they're doing a good thing and that the money is well spent. And that is what drives people to keep doing this sort of research.
Microgravity still has more insights to reveal, and this laboratory, like no other, will continue to uncover them, one experiment at a time.
The people who make the science are just one example of the kind of heroes who work at NASA. Along with the astronauts who fly to space, there are many thousands of people hard at work solving the challenges posed by the space missions of today and those of tomorrow.
So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website.
When astronauts go outside the International Space Station, as Chris Cassidy and Bob Behnken will do next Friday, they're wearing what amounts to a human-shaped spaceship. In this demonstration video, astronaut Ricky Arnold gives us a tour of the critical parts of the spacesuit that keeps astronauts safe as they work in the harsh environment of space.
So we are standing in the Quest airlock, which is divided into two parts. We have the equipment lock and we have the crew lock. This equipment lock has a hatch right here that closes, and the crew lock has another hatch. The EMU, or the Extravehicular Mobility Unit, is our spacesuit, and it's divided roughly into two parts. We have the hard upper torso, which is almost like a turtle shell. It's a hard fiberglass shell, and then we also have the lower torso assembly. These spacesuits are our own little spacecraft, and they have everything you need to keep you alive out in space for 7 to 8 hours, maybe even longer, depending on how hard you're working. The only thing that they do not have, and they have radios, it has oxygen, it has carbon dioxide scrubbing, it has temperature control, it has everything you need except for one thing, a restroom. And so when we get ready for our EVA, the first thing we put on in the morning is a diaper, and that's our first layer. Then over the diaper we put on a pair of long johns, and that's to keep our arms and legs from getting scraped up. It also provides a little bit of wicking in case you're getting really hot and sweaty. The next layer is our liquid cooling garment, and the LCVG has little tubes running through it which allow water to circulate inside the LCVG to provide cooling when we're outside working really hard. So we've got the diaper, we got long johns, we got the LCVG, and then we're going to wear our spacesuit. 7 layers from the bladder on the inside, which maintains pressure, and that's a rubberized bladder, all the way out to the white layer on the outside. The crew member inside the spacesuit is also wearing this, what we call a Snoopy cap. It's a communications cap. We have a radio, so we can talk to not only to Houston, but we can talk to people on the space station and to each other. So we wear this communication cap inside the helmet. Also another key component of the EMU, or a spacesuit, is the helmet. You can see the helmet has a gold visor, which protects us from the rays of the sun that we can bring down. It's pretty bright out there, and this gold visor helps reflect the rays of the sun so we can actually see and operate in daylight. At nighttime, we can raise this visor up, gives us a clearer view, and additionally, we have helmet lights built into the helmet. On top of the helmet, we also have a television camera, so the ground is able to watch us while we work through these TV cameras. The work is really all done with hands, and so our gloves are really our most important piece of equipment in order for us to work outside. And one of the real challenges of a spacewalk is you have this heavy gloved hand, which is inflated, so it wants to stay like it's blown up like a balloon. But we walk by grabbing onto handrails and making our way along the ISS. So every time you move your hand, you're fighting against a balloon that wants to inflate. And then on top of that, all of our equipment is based on using your hands too. So after 6.5, 7 hours of kind of fighting against this glove, it's a really long day, and your hands are probably the thing that are most exhausted after 7 hours out on an EVA. Well, we're going out to work. You probably saw me move this mini workstation. The way we carry our tools is on a mini workstation, which is carried on the front. Every single tool we use is tethered to us. We do not want to accidentally create satellites. Our primary way of remaining attached to the ISS, if we're not using our hands, are these waist tethers. And you can see they just have a big hook. They go around a rail or anything else on the ISS and latch on, and it actually has a locking mechanism as well to hold us nice and tight. So we always want to have one of these attached if we're not holding on with our hands as well. The back of the EMU has our life support system. The life support system contains all the equipment we need, from a UHF radio down to the oxygen tanks that provide primary oxygen. One of the challenges inside this sealed environment, it's very easy to carry our own oxygen with us, but we generate a lot of carbon dioxide, particularly when we're out there working very hard. So to combat that, to deal with that, we have these canisters called Medox canisters, which are just silver oxide. They are carried in the backpack along with a very large battery, which provides all the electricity for us. I don't have a battery here to show you today because we're in the process of charging them. We're about a month out from doing a spacewalk, and we've already started getting ready for that. So this Medox canister is able to remove about 7 to 8 hours of carbon dioxide that a human can generate inside the spacesuit. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
"240 different human beings, so far, have had the opportunity to look down at the Earth from the windows of the International Space Station. Some of them, like NASA's Tracy Caldwell Dyson, have had more than one visit, and she's one of the many who say that experience has changed their perspective on the planet.
My first look at the Earth from that vantage point was on ascent in my wrist mirror, looking at the aft window behind me, knowing that I was the first one that had to get out of their seat and film our external tank falling away. That was my first job, aside from all the monitoring that I had to do. And so my view of it was very fleeting and very technical. It was background to the task that I had at hand, and that was pointing a camera at an external tank so that it could be analyzed. Then when we got into orbit, we had a very fast-paced mission, which all space shuttle missions were. You had 10 to 12 days of fast-paced work. And it was my commander, Scott Kelly, who carved out 90 minutes of entire orbit on flight day 10, and he said to the rookies, the three of us, I want you guys all in that window, and I don't want you to move. And he already pre-coordinated it, got the lights turned off on the station so we could see everything in its grandeur. And that was the first moment that I had to really soak it in, and discovered a lot of things about my reaction to that view in that relatively short period of time. And then, of course, there was my space station flight where I lived up there for 6 months, and every night that I could, I was planted in that cupola, much like the picture shows, and gazing at it. And there wasn't a single regret I had about the time I spent there. In fact, it almost, I dare say, grieved me to think about how in the world am I going to describe this? There's no words. There's no picture I could take to do it justice. There's no watercolors that I could put on paper to come close to the vividness, the ever-changing picture that I see staring at this planet. Everything from the colors to what changes the atmosphere goes through, depending on where the sun angle is and whether the moon's in the view or not, to just how fast we're going over the surface of it and the way shadows are changing. You could see the same landmass over a period of 2 weeks and it looks completely different because of that. To then looking at the stars and the blackness, a black that nothing here on Earth ever can replicate. And then you look at the space station around you and you're like, this is amazing. And all the people who are a part of this structure that are, I know, either at their desks, creating the next great marvel, or they're sitting in mission control, controlling everything I see. And that's where it kind of hits you. You are but a small fraction of the human race that will ever get to see this the way it is right now.
If you'd like another look at any of the stories we showed you today, check us out on YouTube and Facebook, right there at those addresses. Be sure to look around. There's lots of other cool stuff to see about NASA and America's human spaceflight program. If you're interested in good conversation about human spaceflight and space exploration, check out Houston, We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. New episodes post every Friday, and today Gary Jordan talks with three of our friends, three of the photographers on staff here at JSC, about their jobs capturing the images, both daily and historic, documenting the human space program in America. Go to nasa.gov/podcasts for today's episode. It's where you'll find all our previous episodes too. In fact, the full library of all the NASA podcasts right there. They are all also available on Apple Podcasts, Google Podcasts, and SoundCloud.